my name is Paula Jai. It's Januszkiewicz. It's quite a complex surname because I come from Poland. And I have established a company called Secure that has two kind of branches. One, Secure Academy for education, another one, Secure Consulting. And what we do, besides educating, we do penetration tests. This is my job, I do penetration tests. What is else additional here? I've got access to the source code of Windows that allows me to write different kinds of tools, cool tools with our team. And we've got right now 4 offices. One of the offices is in US, in New York. So pretty much that's my story. Of course, I'm a security geek. I don't have any hobby besides my work. That's kind of sad. But at the same time, it's kind of cool because basically this is the only subject that I always talk about, security. Anyway, before we start, if you want to have like a little bit of adrenaline before we move on within the session, this is the quiz. Please take it. It's just fun. It's 25 hardcore security questions that I created to see how Ignite is doing on security. I want to know. I can tell you that on average, people answer 13 questions. So that's kind of okay, yes? So hopefully you can do better. Check out. And if you are ready, you can show me the results. I will be happy also to spot that. Anyway, let's move on. The whole story and the whole inspiration for the session, it's not maybe related with this little cat that you see, but it's related with our customer. Our customer, it's from the factories world. So they're actually processing different types of resources for energy. And what happened to them is that they have been attacked. Nothing really special, right? Considering the fact that that particular factory was off for 2.5 days. And later on, as it appeared, it wasn't someone from the outside. It was actually a person from the inside. It was an administrator that was putting their infrastructure down couple of times in a row because someone apparently paid him. Not a cool story, but by looking at this guy, because we actually had a chance to meet him, he was kind of like very cute looking guy, very nice, absolutely smiling, and so on. You will never say that this person has something to do with such a horrible story. Now, what is the conclusion coming out of what I'm saying? Well, basically, when we were performing the research, we were searching for the evidence in a lot of places and so on, but what we have found out is that these guys' laptops logs in the event log, they were blank when the attack was happening, more or less at the same timing. When it happens once, that's fine. When I check out that there's like a loop when the attack was happening for the second time, that's kind of strange. But this is something that was happening over 10 times. When attacks were happening, there were no logs. No logs, no logs. So what this guy was doing, wasn't he like taking some offline image, booting up from this image and then performing the attack? Probably yes. So what is the conclusion coming out of that? Is that sometimes when there is no evidence, this is a good evidence to start the whole tracking because it allows us to get into more and more conclusions. Within this session, what we're going to be discovering are the places where the data is stored and how we are obviously get access to it. Now, my sessions sometimes are entertaining. Sometimes they're like super intense within the demos. This session, I will not be funny, if you don't mind, because we're talking about the serious stuff. So I'm going to be researching what is stored on the drive in the different kinds of ways. And I will, of course, share all the different scripts with you. Let's start the little analysis with the disk. So what kind of types of traces do we have on the disk? Well, basically, whenever we're thinking about collecting evidence, disk is one of the great evidence that represents us the history of things that were happening over there. But disk is not the only option. There is also a memory. At that certain stage, I have to say that in order to have a disk properly imaged, you need to have a different types of forensic tools. For example, starting with sysinternals tools, disk to VHD, to image the drive first, and then we're going to have an image, we're able to proceed with the further analysis. The reason why it's like this is because if you're going to even touch the disk, the first thing that you modify, for example, it's the USN journal. And then you could have clear information in it, but apparently because you were mingling around, you don't. USN journal contains the history of everything that is happening within the disk, within the journal. Of course, if it's turned on. Now, one of the things that we see is that whenever the company is working on the images and they migrate the image and they have them for like a long time and so on, not necessarily the USN journal is on. We're going to be talking, of course, about that. What else is interesting? Well, there's a lot of user-related data within the user's profile. Anti-user, it's nothing but a registry hive that contains information about what user was opening, the recently used files, even what the user was painting in Paint we are able to spot, but everything is obviously related with the disk. We can see also things like prefetch. Prefetch is pretty amazing because prefetch is not related to the user profile itself. It's a workstation based. So regardless if you got 10 users or 20, prefetch is only one. And if you are like, is it possible to track down what kind of processes were opened or running within that particular system, and even though you don't have a process tracking turned on, answer is prefetch. Not only you're going to see when things were running, but what kind of things were running, but you can also see what kind of DLLs, files were open within those processes, and how many times this was happening. So disk, it's a huge place where we are able to spot different type of information within the attack. Now there's always a little battle. Who is smarter? We are or hacker is? Yes, because after the attack we can obviously clear the traces after each other, but there's always this like a little, okay, so I cleared these traces, but there is somewhere a data. And I can tell you, because we do different types of forensic projects, that there is always something that you can refer to. Not everything can be used as an evidence in a court, but at least you've got some answers. So let's start our demo spree, where we're going to be analyzing the data on the disk. And the first thing we're going to start with is, of course, related with the Windows indexing service. Windows indexing service allows us to gather information about what is being indexed. So if, for example, you enter different types of files, you open them up and so on, this is the information that we're going to get. So if hacker, for example, had some tools, opened some files, went to some websites, stuff like that, from Windows Indexer, we're able to grab that information. Windows indexing is actually quite big. And in order to be able to get access to it, what I will need to do at the very beginning, and this is the first moment when I'm pulling out my PowerShell, let's bring it on, there we go. So we're going to do, at that stage, the snapshot. So we will need to use the shadow copies. Now, because I'm running this on my local machine, Windows 10, so there is no like VSS admin where I am able to create shadows, but nobody said that creating shadow copies is impossible. So this is like a little PowerShell script which allows us to create the shadow copy and create a symbolic link by using the mclink command to map it to C shadow copy. So I need to be running for that command the console as an administrator, and at that stage, let's just do it. So what I'm doing right now is that I am creating the shadow copy and I'm mapping this to the C shadow copy drive. So this is a little bit of a case. Perfect. So we've got right now our C. We can get into C drive. Actually, first let's go to the C drive, of course. Now we can get to our shadow copy. And over there, this is the exact copy of my drive. So not a big deal. Now what I would like to show you is how Windows Indexer works and how we're able to pull out information from the indexing service. So we've got that. At that stage, what I need to do is to get into the following directory, program data, from that stage, data. And then, this is good, I need to go to Microsoft, enter, and I need to go to search. What is it? Because it's missing. I can do start dot in order to open the GUI, and I can move forward like this. So we've got our data, Then we've got our applications, Windows, and technically the biggest file that we have over here, it's 7 gigs. It's actually pretty big for me. That's the indexing service. Now, basically what I will need to do, I will just simply speaking copy it to my C drive analysis over here. So I got already this one. I think I can just delete it. This is for my backup, and that file will be the one that I will be able to use for the analysis. Now, of course, question at that stage is what kind of data, what kind of tools and so on we're able to use for that purpose, yes? So there are plenty of tools. One of the tools that I will be using, and I will open it at the regular user right now because I don't need to be accessing to the administrative folders right now. This is this tool, ESC Database View. This is the tool that you can get from Nearsoft. This time it's not a tool that our team wrote, where we are able to load our indexing database. Let's do it. Absolutely. This is C analysis, open, and this database, so 8 gigs, it's quite a lot to process, presents us the history of what was happening within this box. Now here you've got different types of objects that we can refer to. One of these objects, we can select this one. The analysis takes a little bit of time, will display us different types of components that were affected. Yes, so analysis, put NXT, CoinVault, and I've got a bunch of samples here. So these are the folders that were affected. But a little bit more detailed information we're gonna get over here. So here I'm able to search one of the things, for example, for stuff like .exe. So what kind of executables I was launching. What is best is what is indexed over here. It's not what operating system processes in the program files. This is everything that you've got in your profile, so app data. So this is the place where malware can extract. This is the place where someone can drop their tools and so on. It's not a place like program files that we are able to refer to. So for example, here I see that I was playing with NTOS kernel. That's kind of interesting because NTOS kernel, it's not in app data. If it was, we would be in trouble. So this is actually a symbol file that I was referring to. So I was doing the debugging and this was one of the things. Hopefully I will not find here any compromising websites for me like gossip portals and stuff like that. In US, you've got the TMZ. I'm not reading this. Definitely not. Okay, so let's see. NTOS kernel. All the time I've got different files, but for example, yes, over here I was playing with an executable .NET logs, yes, one of those, and I was also here entering different types of websites, yes, so we can spot, for example, that I was an NBC News, incidents of ransomware on the rise, FBI.go, I wonder what I was doing there, but anyway, so we've got things like this, so you can see not only what kind of websites people were browsing. Even though you delete the history, it doesn't matter. It was already indexed, but also what kind of files people were opening. Yes, and if you were wondering, like, oh, were any Mimikatz running? Yes, then I've got here another stuff. Yes, Mimikatz server and stuff like that. So we're able to spot a lot. So right now you've got 8 gigs of data to review upon your own searches about what was happening in this box. Okay, so this is the first thing. Second thing, what about prefetch? Is there something interesting we can play regarding this? Absolutely. Prefetch, natively, it's within the C Windows prefetch folder. And having this in mind, let me show you the tool that we wrote, which is called a prefetch analyzer. And within the prefetch analyzer, we are able to spot, as I said, how many times different executable was launched, what kind of DLLs are in it, and stuff like this. So let's get into our tools, and I've got CQ tools, and we've got CQ prefetch parser. And CQ prefetch parser, it's a tool that is written by our developer, Michael. Our developer, Michael, is a kind of special person. Probably you will never see him speaking here because he doesn't really talk to people, like at all. The only people he talks to, and he really said one day that, hey guys, in our team, like, the only people that I would like to talk is Greg sitting over here in the front row and myself. Like the rest, I don't really feel comfortable to talk to them, so just skip this, okay? We're like, wow, yes? Would you believe that Michael has 3 kids? How did it happen? Nobody knows. Probably he's lying to us, but anyway, they're real, I saw them. Maybe they're robots he developed. Anyway, so let's have a look. So here I got also dear PF files. So these are the ones that I already copied from the prefetch folder. And our prefetch parser, let's just take one of those files. It could be really anything, could be this one or that one. And we are able to specify within -f for file and -a for analysis. Now, let me tell you something, why this is cool. Because it doesn't maybe sound very breathtaking, but let me tell you, in Windows 10, if you are playing with your forensic tools, with Prefetch Analyzer, your Prefetch Analyzer in Windows 10 will not work. Because how Prefetch is managed and saved, that changed. So that's why we wrote our own tool, which is free. You can download it from my blog, and you can use it for the analysis, where these prefetch files, they are compressed and saved in the form like this. So this tool allows to play with the prefetch not only for current Windows 10, but also it has a backward compatibility. That's kind of cool. No, let's have a look, like what kind of stuff do we see here. So we see that notepad was executed in the following times. Yes, so we've got run count, 47, so many. Yes, the last executed times. We've got all of that. We've got also here different types of references of the DLLs that were loaded. We're also able to see over here what I was actually browsing. So not only you got what was launched, but also what was opened, for example, within the certain file, putting this in the normal language to what kind of stuff we had handles to. And when I was opening Notepad, I had this file open, means I had a handle to it, so let's record that. And that is something that we got. You need to check, in order to be playing with this, if you have prefetch turned on. Because on some of the drives, it can be turned off. When you're gonna pull it out from the registry, you're gonna see value 3. That means it's all good. If not, I would recommend turning it on. Now, sometimes, don't be afraid, you're gonna find in this kind of like, I call it cheap like tips and tricks forums of IT guys where you can find information. Ooh, if you wanna save disk space, delete prefetch. Well, you have just saved 100 megabytes, congratulations. Don't delete prefetch. It's a very, very useful piece of data, but it has to be, of course, turned on, but that's the one that allows us to get information from what was launched. Okay, guys, now, what about the other stuff? Well, the other stuff, when we think about different types of tools, there is something that is called automatic destinations. And automatic destinations allows us to get access to all the different types of cache that applications were caching in order to offer to the user later different types of data. So this is another cache that we've got within Windows. Now, question of the universe is there, what kind of tool can we use to analyze automatic destinations in operating system? Well, I would suggest this one, but there are plenty. Structured Storage Viewer. This is a free tool you can download from the internet, but in order to open it up, I have here a little bit of a cache. Have a look. Oh, this is in C users. Apparently, this is not enlarged. So let me do it like this. So we can open it, and automatic destinations are within the user profile, like this. Roaming, Microsoft Windows recent items, automatic destinations. Now this folder is hidden, so you kind of need to type it. Yes. Now these areas, they're all described in Wikipedia. And if you're gonna search for the list of jump list identifiers, there is a known list of software that writes data into automatic destinations. For example, Notepad has a predefined tag, and a couple of other software that is known, they all have predefined tags. So we can, for example, get into 9b, this one, over here, 9d. This value here represents as a notepad. So if I get into this, open, what happens is that I got this little view here, and already here, I'm able to spot on the right side, for example, different types of text files opened by me in the whole history of the operating system from the moment it was born and you installed it to the analysis. This is not cleaned. So if you opened something for the past 4 years, I'm able to trace of what was actually accessed by you within the whole thing, for a whole time, from the beginning of the installation of the operating system. Very cool. So if you wondered, did the user actually access this data? Was this data accessed? Where the user was connecting to and so on? This is the place where you're able to pull this information out. It's called automatic destinations, and by default it's turned on every operating system. So this is what we've got over here. And it doesn't really matter like in what mode do you open a file and so on. This is the regular opening of the file. So we are able to spot this over here. Okay guys, so we've got that. Now question is there any other cache that is interesting for us that we are kind of able to pull out? Absolutely, there is. One of the interesting things that we can refer to, that is something that we call a remote desktop cache. So whenever we've got a remote desktop connection made from the certain workstation, what is pretty interesting is that every single time, I don't know if you knew, but there is actually a cache being written into the local user's profile. Now, where do we get this information from? Well, let me show you, because this is kind of cool. For that purpose, pulling out the machine, I'm going to use the tool, which is called RD Cache. And tool RD Cache, it's a kind of like, I would say it's one of the most ugliest tools I've ever seen. And what is kind of funny about it is that this tool is actually written by the person who I call our secure team member, but with the benefits, which is technically my husband. And that's kind of like the gift that he gave me for like a name's day or something. Yeah, so not a very romantic person, isn't he? Yeah. So we've got this. So when we do load, we've got here the path where we are able to get the remote desktop cache. It's on every single person's computer. Every single time you do MSTST, this cache is there. Remote desktop protocol works in a way that whenever you have things displayed, it puts the grid on the image and it downloads those grids. Probably that's why you've noticed that sometimes when you've got a slow connection, the image it's just inside the remote desktop connection, it's kind of like blurry. That's the reason, because the quality of the picture is getting like lower. So in cache, you've got all these grids. This is kind of cool because if we are able to trace what some person saw, where else if not in there, if this person was using remote desktop connection. One more thing, open, okay, and now the code. Now, it's really your turn to put all together these puzzles in. Just kidding. This is not working that badly. It means for me that this grid that I've chosen is just too small. So putting it a little bit more logic into it, I will specify that it should be 64 length. And now I'm able to see, of course, all the different things that person could see when connecting using the remote desktop connection. And yes, it will not be nice and pretty. Besides, we could be thinking, is there any logic on this puzzle? No, because if you move window within the remote desktop connection, the grid stays the same. So it's like one more grid. There is no logic on the top of that. But it doesn't really matter, right? Because we are still able to see what kind of stuff this person saw when connecting to the remote machine. And question to you guys is, what is this? IIS, thank you. Who said this over here? Thanks. I got a t-shirt for you with the raccoon. As I was saying on my previous presentation, don't wear it in the Arab countries, okay? Because it says pass the hash. It's waiting for you, okay? Thanks. Okay, don't put yourself in trouble. Okay, so this is one of the places. Good. So we can spot just one of the caches. Okay, guys. Next one is, what about a metadata? Is there something that we are able to extract from there? Absolutely. Yes, this is what we're going to do. So I'm going to get into the D drive, and I would like to show you how we are able to play with the metadata files. What do I mean by this is that every single file has last access date, the write date, and so the creation time, modification time. So this is something that sometimes we rely on when we are performing the malware research. We're like, oh, we got hacked. Let's find out what kind of files were accessed within the past 2 days. Well, I will tell you something. This will not save you. If hacker was smarter than you doing this research, this is changeable. Every single metadata of the files, it's changeable. So we could be like, nothing really interesting within the past 2 days. Exactly, because we have changed the metadata of the files that we dropped to be like 10 years ago. That's my point. Let's have a look how to do that. So I got here a drive. This is an E drive, and that E drive, well, just contains a very simple thing. When we have a look, this is just data folder where I got like all the different files. They're all the same. They're all the same. So just to prove you a couple of things at the very beginning, we will run at that stage and group all the objects by the hash. They are grouped in one group, which means they are the same. That's my point, yes? So we're able to check out, yes, at that stage, what is the last write time of all of these guys, yes? And we're going to be playing with the modification of the files in a moment, yes? So this, for example, let's take one txt, and let's list getMember has the 3 following properties to be set. What is interesting here is that we see that we've got a creation time, last access time, last write time, blah, 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 but then we also have something that is here called set. Nice to know. Not only we can read it, but we can also write it. So why don't we do this? Let's learn how to do it. So what I'm going to do, I'm going to take one of these files, let's say number 4, and number 4 says this is a real data. I'm going to specify this is a fake data or something. Save. Good. So we have changed that right now. We can spot over here that date modified is a little bit different. Let me take this out. Also, when we have a look at what is at that point the last write time per grouping, this guy stands out, okay? So now, what if we overwrite the whole thing? And that's exactly what we're going to do. So we will, first of all, sign up into variable the last write time of this file that was somewhere out there. And for every single file in the data directory, we're going to overwrite, yes, we're going to overwrite the whole thing. And last write time, last access time, and creation time, and so on, they're going to be all like last write time. So why don't we do this? Let's do it. And perfect. So we have just overwritten all of the data. Now we can go back to grouping and find out what just happened, and by the last write time, they're all a single group again, because I have just overwritten the whole metadata of that entry. Yes? So there is not much trust we can put in this. Now, there's a lot of different types of forensic tools that display you the last changed data. It's not bad, because it really depends who was smarter, hacker or we were at that stage. Maybe, hopefully, we will be the ones winning this game right now. Okay, guys, so this is how we have it. Now, question is, okay, but if it was done, is it really that we are kind of misleaded over here? Not necessarily, because what is in operating system working nicely, it's something that we call an USN journal. So there are a couple of ways how we're able to analyze the journal. There is a commercial tool, don't get me wrong, I'm absolutely not advertising it, it's just a very good tool. The tool that is called JP64 from TZWorks. It's not free, it's used for journal analysis, and it allows you to extract information about what kind of operations were happening on a different data in time. So that this metadata of that file was changed. That was the previous value, that's the value that we have right now. We are always able to make this kind of analysis. Now, is there any way we could do it nicer? Absolutely, yes, and this is not really something that we should do in PowerShell 2, but we can just do it within the regular command line. And this, fsutil usn read journal on the E, we are able to run just like this over here within the command line in order to read the USN journal, so the history of transactions made on the disk. You have to be an administrator for that. And over here, I'm able to review what kind of data was changed amongst the file. For example, here, my journal, don't get me wrong, it's very short. Your journal in the regular drive, it's going to be huge. So it's nice to have some analysis tools anyway, but for us, that Windows built-in tool is good enough, or you can just parse it, that's fine. So here I've got the 4, yes, and we've got a basic info change and so on. When was this? But that's not the only info that I've got over here. Data override, data extend, and stuff like that. This is for the desktop ini file. Object ID change. So I'm able to identify that there was some kind of an operation happening on that particular drive. And that's kind of cool, because it allows us to trace the whole history of what was changed within this file. Okay guys, so this is an USN journal. Now question is there any place in the registry we're able to pull out even more information? Something accessible like immediately. Like when I launch it, that's the moment where I got this information immediately available. Absolutely. I have written a little script where you are able to analyze the current user's session. So what the user was actually doing, and if there was some changes made, then within the, for example, user's profile, then we are still able to trace that information. Let me take the PowerShell out right now. Here comes another PowerShell. So PowerShell as a forensic tool is uber cool. The cool stuff is actually coming, you will see in a moment. But this is a very simple summary of what we are able to pull out from the people's registries. For example, have a look. Can I get the profiles list on the disk? Yes, I'm just listing the directories on the disk. It's absolutely not a big deal. So I see that these are the users that were logging on into this box. Were they really? So if I, for example, get profiles by the SIDs from the registry, is there something more than I'm able to pull out? Absolutely yes. So if I do this is a kind of a bigger list. So it means that there is something that I don't know about. Now, can we check that? Sure, because within the registry, there is a whole history kept of what kind of profiles were created. Disk, it's not a good reference for you. Registry is. Have a look. I got over here something new. And I see that who was logging on was, for example, a hacker, which wasn't before. That's the history of the profile that we pull out from the registry. So if you're wondering, were user logging on in this computer, oh, there is no data in the profile, check in the registry, because it's going to tell you all the necessary info. Now, who was smarter? User was? To delete this stuff from the registry? I doubt. You're going to be, because you're going to see this kind of data here. And of course, we are able to pull out much, much more things. Also, information about what was within the Windows R. Do you hear this, or am I the only person? Okay. Someone opened the fridge with the ice creams or something. Okay, anyway, so we can see, of course, what was in Windows R. We can also see what was within the MMC. So this is easy, yes, just to show you that this kind of information is out there and we are able to pull it out if we want to. Okay, guys. This script, as I mentioned, will be available on my blog, so just enjoy, and you will be able to practice everything from home, because all of the stuff that I'm presenting, it's just to be migrated and applied. Okay, guys, so long story short, we were discussing about the stuff being on the disk. Now, is there a way we can kind of mingle with data? Can we hide it? Can we make it not visible to people? Besides just hiding it, yes, by changing the attributes. Of course, we're able, for example, to put one file into another file. We're able to use the alternate data streams. We're able, for example, to embed one content into one content. Executable itself, it's a kind of spoiled file format. Executable, when it's like, when you add something in the end of it, it wouldn't mind, it's fine. Of course, it can break the signature, but okay, but executable itself will run without any problem. So there are plenty of ways of hiding data. What I would like to show you, it's kind of cool, because we will be playing with the PowerShell data undelete. While there are so many different types of tools that you can use to discover and get your data back from the disk, from the different file systems and so on, PowerShell can do this too. And you can do it absolutely easily. Plus, there are two ways we should know that if we delete data from the disk, and even if you encrypt it over, not every single data is still deleted. Let's talk about this. So, next demo, it's related with the recovering data files, which is called data recovery. And for that purpose, guess what we're going to use? PowerShell. Oh, of course. Very cool. So, I got here a set of PowerShell commands that I've written up for the demo. And we're going to be playing with the disk that was given to us after analysis. So this is the X drive. I have already mapped it. This drive start dot. It's actually quite straightforward because over here we've got this stuff. Yes, this is just mounted drive, freshly mounted drive. And we can see that there is nothing on it. Well, apparently someone deleted the data. So is there a way we can find out if this data was deleted from that particular file and if there was any data and what's the history and so on? Absolutely. So in order to do that, we will, well, just to do dir, yes, you see that there is not much. I'm going to use here a PowerShell module which is called Power Forensics. It's a free module that everybody can download from the internet. First of all, I have it already installed, but if you want to set it up for yourself, you have to do install module and Power Forensics, and you need to drop it, of course, in the place when the PowerShell hosts all the modules. Now you are ready to go. Guys, you can have the same fun. Plus, I need to tell you one thing. I think it's really cool and everybody should be able to know how to do that. On my blog, you're going to find a 100% recipe with the different types of disks which you can get, and you can do the analysis by yourself. If you're wondering, well, I don't have a data to work on that, well, no problem, we provide it. So learn this, because it's actually a very useful skill for forensics and getting data back. Okay, so what we're gonna do, first of all, import module Power Forensics verbose. Here we are able to spot different types of CMD LEDs that are mostly, as you see, get. Sometimes we've got convert from and so on, but most of them we use, it's for grabbing the information. Okay, now what we're gonna do here, get forensic file record. Let's find out what kind of files were basically deleted. And over here, we don't see much information. I wonder why is that? Let's see, because we should get here the deleted file. Oh, that's interesting. I wonder, let me check. I'll mount the drive and mount it back again, because we should see something. Okay, anyway, let me do it one more time quickly. I will just eject it. This is kind of strange. Okay, let's do it one more time, and we should be all good based on that. So we've got an X drive, let's do it one more time, and the same story. Okay, let me check with the drive, because we should get some kind of data here. Okay, sorry, here we go. I will just eject it. Okay, and I will get this file over here. Should be good. I'll just use a different location. The location is good, but I got a backup. Let's say analysis from here, and let's try that, because I kind of don't like what I see. I will eject it one more time. No, this is good. It's ejected already, and let's run this. And let's find out what stuff we have here. Okay, lovely. We're back on track. Apparently, maybe my image wasn't good. We've got it. So we've got here a deleted file that is p.exe. What is kind of interesting for us is the record number. So this particular record number over here that says 38, this is something that I was talking about within my previous session. So this is an inode. So this is an identifier of this file, so kind of a number of this file on that particular disk. So in order to get some information about it, I want to get forensic file record variable. I'm going to set it up first for the index 38, and I will display the different types of attributes of that particular file. So this was a p.exe, and now we're able to see that we've got here different attributes. Like for example, here you see standard information and file name. That's another one over here. So this is different attributes that we can get, and we can see also Power Forensics NTFS data run. And this is something that is very cool for us because this is the place where we've got this file stored. We're able to extract this file exactly from that particular place. So the data attribute, data attribute that we've got will allow us to get information about that particular file. So let's do it. I'm going to specify that I would like to get this attribute, so equals data. So we are choosing this attribute, setting it up at the variable, and let's display what is inside. And we can see something cool, that this particular file that was deleted, it is within the following place in the disk, starting in this cluster with an offset. So cluster length 130. Now, this is not information that is enough for us, because, I mean, it's good to know that it spreads across that amount of clusters, but I need to know what's the cluster length in order to be able to suck this data out from the disk and eventually start as a file. So this is something that we should have a look at. Okay, now let's get forensic volume boot record information to pull out for us what's the size of a cluster on this disk. Very simple command. Let's do it. And we can spot over here that we've got bytes per cluster, 4,096. And this is the value that we will need to take into consideration. So let's have a look. When we know the size of a cluster, we know how many clusters we've got, we know what's the offset, the only thing we're supposed to do is to take this data out. So this is a data recovery. So what we will do, invoke forensic TD in file, and we are specifying an offset, where to start from, and then block size, of course, which is 130, and we are saving this in the text.exe. Let's do it. So at that certain stage, let's check out if in my analysis folder, I got the test.exe. This is exactly the file that I have written right now, test.exe. In my country, I'm from Poland, by the way, it's 7:12 p.m. So what do you think that is? Americans says patty. In Europe, we say putty. So, but this is definitely patty, yes? So what is interesting about patty is that if I open it up, click, click, it works. Yes, if I, for example, check out bank properties, question is it digitally signed? Well, no. Well, patty is actually digitally signed. So is it possible to pull out the files with the digital signatures? Well, let's see. What happened over here is that knowing the size of a cluster, guys, I just did from the beginning to the end, and apparently my executable was over a little bit earlier. So that additional data, when I was saying that executable format is spoiled, that's exactly what I meant. It's not a problem if you add something on the top of it. It will lose a signature, but it will still go. So at that stage, question is, are we able to move further and do a little bit of fun in the recovery of what we've got with the, of course, digital signature. Okay, let's get into our variable, bank. And our variable for data says the following, that we've got allocated size for the file, but the real size, it's a little bit less. So what I did, I have used here the allocated size by just providing the size of the clusters, but can I really get this file with the signature back? Sure. Let's have a look how to do that. So what I will specify here, and that's going to be nothing really breathtaking, it's just a regular operation on the data within the PowerShell. I'm specifying that variable bytes, we are reading the test.exe, and I'm just cutting it to the real size. If you're wondering why it's not ending up with 8 here, it's because within the array we numerated from 0. So it is actually the actual size of the file, and I'm saving it as a test2. Okay, so let's have a look what kind of stuff we're gonna get. So I got it. Now let's verify within my analysis if there is test2, that's the one that was just created. If I go to the properties of this file, what it says, digital signature, thank you. We're able to recover the file 100% how it was deleted from the particular drive. So this is the information we are pulling out from MFT. If the file is deleted, MFT knows where is it, yes? You're not really at the end deleting the particular file. We're able to pull it back always from the disk, regardless the size. What is good for us, by the way, is that this particular file wasn't fragmented. If it was fragmented, we will need to gather all the fragment all together, and then we will still be able to get the file. I mean, getting data from the disk, it's not a romantic process, yes? It's just to pull all the information out together. Okay, now it comes my favorite trick. And the reason why I'm saying this is because I would like to show you how we are able to pull the chunks from the disk, even though we think we've deleted them. We have encrypted the drive and stuff like this, but the truth is that, well, let's see. So what I'm gonna do, this little loop will create me different types of little files, and they are in the content, they will all have secure inside, and they are all called wipe me something something. So a lot of files, not a big deal, let's do it. Yeah, okay. And we can of course check out what's the whole case, yes? So we've got plenty of files. Now what I will do, start dot, again, I will, from this drive, delete those files. And I'm gonna just select them, and just to make sure, not with this, just to make sure we are all on the same page, what I would do, I would just shift delete it. Yes, so let's bring it on. So shift delete, are you sure? Yes. So these files are no longer there. Now question is, are we able to pull them out? Well, as we know we do, but let's be cruel. What if I just encrypt my drive and overwrite the whole data out there? Let's do it. So Cypher is actually a pretty good way of overwriting data, but it doesn't work in every scenario, and that's what I want to tell you. So let's do it. So our stuff is already deleted. By the way, it's a kind of funny way how Cypher works in a PowerShell, because these dots, it's supposed to be something being displayed as a progress, but because PowerShell cannot process it correctly, dots are displayed at the end. Yes? So really kind of like a geeky joke. Okay, anyway, let's move forward. So what we will do, well, let's see, of course, what kind of files we've got within the drive. And what I will do, let's pull the 0. Get forensic file record. Let's display at the beginning information about this drive. So we've got here at the encrypted drive, MFT. This is pretty awesome, because if we check out MFT, and what's the parent record number, number 5, over MFT, let's see what's 5. Is that over here, it's actually X. So the root drive. Isn't it funny, by the way, who was first in this world? Egg or chicken? Yes, because MFT is actually on the root, but when the MFT was created, the root wasn't still there. So that's kind of like weird. Well, it's not at the end, but when you analyze it, it's funny to look at that. But anyway, what we're gonna do, we're gonna, of course, at that stage, well, specify that we're gonna copy, of course, certain information about the drive within the XMFT, so that we are able to see what is inside MFT in the text file, okay? So I will open up this file, Let me pull this out. We've got this in a C analysis. Okay, very good. Bringing this back. And we've got over here XMFT. What is this? Now we're going to start analyzing this. Just kidding. No. But this is MFT. So this is how it works. But what we have MFT in MFT, have a look. It's the content of our deleted files. So were they really deleted? How could it be that if I deleted it and I overwrote them, they're still visible as a part of the MFT? So they were not deleted at all. And that is exactly my whole point over here. Why this was happening, it's because whenever we are thinking about how these files within the structure work, well, basically within the NTFS, the small files, approximately 700 bytes, even though when you delete it or not, they're not wiped because they are residing within the MFT. And this is something that we sometimes call like residing data or resident data. Yes? So little files, even if you think you've deleted them, no. So if you got like a files with passwords and it's a text file, if you're like, oops, let's delete it or something, nah-uh. After encryption of the drive, it's still recoverable from the MFT content. So just a little case on the top of forensics. And of course, question is, what can we do further? Yes, can we, for example, play with those files? Yes, so let's have a look. And that's the little last thing here. Yes, we're able to check if we've got the file, for example. And I got, for example, one of the files is being recovered. This is the wipeme.txt. And if I open it up, it contains all the data that we've got. Yeah? So this is the information that we are able to pull out. Okay, so this is how we are able to get access to the small chunks of data within the disk. And next stage, really, yes? Because as you see, there's plenty of information that we can get. One of the things that we are able to also have a look at is the memory and all the different exciting traces that we can find over there. We'll not be analyzing memory in a very detailed way over here because probably we'll not be able to finish this up until the next week. But I would like to show you how we're able to extract different types of data in the memory that after you experience an attack, the memory dump should be the first thing that you should do. Second, we should be starting to analyze what was in the memory because whatever works in the operating system is going to be always in the memory. So there are plenty of things, like for example, one of the most important things to refer to is handles that I was mentioning before, handles to files. If I have a handle to the file, probably I'm able to pull out some information about that file from the operating system's memory, from the memory dump. And when we already possess a dump, which could be performed, for example, by one of my favorite tools, which is free right now, this is really exciting, it's called Dumpit, it's written by Matthew Swish, and this is a very easy to use tool. You got the tool, you got the memory dump of the virtual machine, either the physical system, and now you are able to move on. What I would like to show you for today, it's a technique of extracting event logs from the memory. The reason why this is uber exciting is because this is a tool that we had to write up for our customer during the forensic project, so it has a very practical background. Second thing is that EVTX in the operating system, it's a very difficult format that is digitally signed in many different places, so while you can mess up with EVTX, it's a no-no. When something happens, the log is immediately corrupted. So let's see how we are able to play with the log extraction from the memory dump. I will be doing this within the command line, of course, because what is needed for that, it's first of all, it's a volatility that I'm going to be using, and the second, it's going to be our tool. Now, a couple of words before we move forward. Volatility, it's a free set of scripts that you can download from the volatility webpage. And if I could recommend you something for future, is that if you have a choice to choose 32-bit or 64, please pick 32-bit files, because you've got a lot of extension packs for the 32-bit files, for the 32-bit modules. Python 2.7 32-bit, volatility 32-bit, and eventually active Python 32-bit. I know we all want 64, but I'm just giving you a good tip if you want to have a smooth entry into the subjects we are talking about right now. Okay guys, so if you are ready, I'm ready. We're going to use for that volatility.py, where we will specify -f file, and I've got a dump. My dump is stored in tools, dumps, and then I've got analyze.gmp, and I will need to profile it. So profile. In this case, it was Windows 7 SP1 x64. It doesn't really matter here. There are many types of profiles which you could use, Windows 8 and so on. So this is something to just choose appropriate profile for analysis. And then we will specify DLL list, and we can extract this DLL list to txt to get information about what kind of DLLs were loaded in that operating system. Now, if you are wondering why am I doing this, answer is very easy. If I want to get information about event logs in system, how do I know where the files are? Well, this is quite easy. We need to find over here the service, and that particular service, let me get into the place, Windows event log. That's the guy that manages event logs. How do I know that this is this one? Well, if I go to details, the only thing I know over here is that this is SVC host. So the only way of interpreting where is my Windows event log, it's by finding the DLLs loaded by SVC host. And one of these DLLs will be a Windows event log service. That's how. Yes? And based on handles to these files, to this process, I will be able to pull out the logs. So let's dig in. So this is the part that we already know. Now, DLL list is something interesting for us. What we are searching for over here, Control F, it's the event log service. So it's a WEVT SVC. And we've got a DLL, awesome, 848, it's the process ID of the file that we would like to be analyzing here. Because that's the guy that runs our Windows event log service in the memory dump. So let's dig in. So the next stage for that will be quite straightforward. So the same volatility, but this time we will do dump files, and we will specify that we would like to dump the stuff from the process ID 848 into the directory, which is called file handles. So over there, I would like to drop all the information that I've got the handles to from that particular SVC host. And I got all the trash, DLLs, EVTXs, and so on. But unfortunately, these EVTXs aren't really consistent. We will need to try, but I will show you that if I will try to open one of these files, I will not be able to, because, well, it's just like a raw data from the memory. So let's have a look in what kind of files are here. So let's go into file handles, start dot, lovely. And these are the files over here. What will be interesting for me, for example, let's do it. It's an application log. Yes, let's say I want this one. So can I, for example, like rename it to EVTX, enter, and I will just enter it, open it in the event log. Yes, event log is opening right now, just a second. And I got information here that, because the event log file is corrupted, not a surprise. So what I'm gonna do, I'm gonna take this stuff, copy, and what I will do with it, I'm gonna paste it into the tool that we have written to perform that type of recovery. This is the folder of this tool, pang, I have this log here, and let me move to the command line to perform the rest of the steps. We've got here also out folder. As you see, it's empty. This is exactly how we're going to be extracting the EVT access from the memory. Okay, guys. So at that stage, let me clean the screen, and I'm going to go to the place where we've got a tool. Let me launch the tool, of course. And again, knowing the romanticism of our developer, the tool is actually very easy. It has two parameters, in and out. So I'm going to do it like this. evtx recovery in, out, out. Very simple. So in out folder, we will have recovered application evtx, again start dot, to have a look at these logs out. Let's do it. So we've got our out. Let's open it up. Perfect. And in the moment, we will have it opened in the event log. Event log actually opened. And I got here two probes. One is the probe that didn't work, and one is the probe that worked. This is the probe that didn't work, because I have here that the event log file is corrupted. And if I go to this particular one, I have some events that are recovered from the event log, and I'm able to, of course, review all the necessary ones. This is a pretty limited log. I kept it smaller so that I'm not recovering like for the long time and so on. But you see that we made it actually consistent. I'm happy, of course, to share the tool with you guys. Okay, guys, so the next and last stage of our presentation is to discuss different types of preventions and or proactive monitoring for the whole pre-attack situation. One of the things that we've got and the tools to be used, Mark Krasnovich was talking about it, it's Sysmon. The reason why I'm talking about this is because we have written in our team, and this was originally for our customers, different types of Sysmon related tools. Not only Sysmon can cooperate with Splunk, but also you can extract uber cool information from Sysmon, and these are the tools that I would like to share with you. Some of them are allowing us to analyze the information, just this. Some of them is allowing us to extract, for example, some stuff related with the network configuration. So let me dig in. Sysmon allows us to monitor gazillions of different types of events. Actually, currently we've got 10 different types of events, and we're able to spot things like, well, creation of the remote threat, network connectivity, rogue disk access, so all the stuff that can be used within the attack. One of the last things, like process access, so even ID 10, it's very good because it's very nice to trace stuff like Mimikatz and so on. Now, what I would like to show you, it's the Sysmon customization demo and how we can make Sysmon for us in the enterprise to evaluate what kind of IP addresses people were connecting to. So if the machine was attacked, I'm able to see all the network connection that was out there. Of course, what is important is that these logs are streamed out from the box, because if the hacker notices that you are using Sysmon, this guy can simply speaking clear the logs. So let's see how we are able to proceed with this. Okay, so our next demo that is coming, it's Sysmon and the network setup, and getting information about IP addresses and related data. What I will do over here, and that's going to be quite nice, I would like to perform whole operation, let me go to the C drive, on my, of course, what did I do? Like this, on my drive. And my Sysmon is uninstalled in the live scenario. The reason why I'm doing this on my live machine, obviously not because I'm risking here, but because I want to show you how straightforward and easy Sysmon implementation is. So let's dig in. First of all, if I do Sysmon, I have Sysmon running. Everybody in our team has to run Sysmon, by the way. I'm able to uninstall it. So let's do it. Bang. Sysmon is uninstalled. Very easy, very straightforward. If you want to get rid of it, go ahead. The overload on the system is very low. And it's super useful at the same time. You just have to implement it. That's what I'm saying. We love it. So let me dig into analysis. This is the place where I've got sysmon.exe, and I will be able to install it. I want to install it, for example, with, let's say, hashes MD5, for example, and I want to gather information about all the executables and their hashes so that I got this info, I can compare and so on. One of the new things, it's imp hash. It's a new type of hash that only analyzes different types of, for example, imports from the different DLLs. So that means that even if the DLL has many different variants, it's still the same inside. So this is useful for the developer updates for different modules and so on. The file is different, but the inside of it is the same. So we've got this. Now, I will specify that I want to have it within the network, and that's cool. So let's do it. Very simple, very straightforward. Now, if I go to my event log, what I would like to show you is one thing. Sometimes it happens, sysmon, that within the sysmon, even though when we set it up, yes, in this case, I've got plenty of network connections. What I can do, for example, I can clear the log. Let's make it like smaller. I'm just going to clear it. And if I, for example, connect using different types of processes, let's say explore.exe and so on, question is, are we able to spot the network communication? Absolutely. Yes. Now, what if you want to distribute the whole configuration among different workstations? Well, what we did, because sysmon only allows to display the configuration, we have written a tool that allows you, let me get into the place where we've got it, to export configuration into the XML file. So we've got users, in my case, Pula, desktop, sorry, this was the documents, and then I got sysmon, and we've got here CQ sysmon config, and it allows you to export the configuration into the config file.xml, and config file.xml shows me all the stuff that I have saved right now in the sysmon. Because if you want to do it within the sysmon itself, it only displays you this within the console. So you cannot really use it as a file that you can spread across the whole enterprise. So this little useful tool on the top of the whole monitoring. Now, question is, how can we gather information about what is happening within the network? I want to get this info. Well, nothing really easier than this. In our tool, we've got something that is called first sysmon hash extract, but second sysmon net analyzer. And sysmon net analyzer, and it takes two parameters here, their input where the evtx files are and the output file, allows us, let me get into properties and copy, to put information about different network IP addresses that we are communicating with. So I will just minimize this. And it will allow us to create an Excel spreadsheet where we can spot which processes by who and where. I love this feature, by the way, because if you ever wondered who communicates from all of your workstations in the internet and what kind of addresses these are, this is exactly what we're going to get. Let's see. So sysmon net analyzer, we're going to specify the directory. And in our case, of course, it's C Windows. And then I got it system Windows 32 and so on. System 32 and so on. And then we've got out. And we're going to specify it network file txt. So I got here 88 events. Now what is uber cool is that we are able, of course, and it's not a big deal, but I want to show you, export the whole thing, network file.txt, into Excel. And what is very nice is that I will show you a little bit in a moment a tool that allows us to, well, not only take the IP addresses and extract them from the Excel spreadsheet, but also allows us to analyze where do they really come from. So long story short, what I just did, I have imported from our text file data into Excel spreadsheet. On the top of this, you can build table, yeah, so not a big deal, right? And we are able, at that stage, to analyze, oh, I don't want to see things like from program files. No problem, guys. You just unselect the stuff that you don't want. But what is cool over here is this. Here we've got destination IP. Let's take it, Control C. And then what tool I'm going to use for that, let me show you. It's going to be the tool that you can get from Nearsoft. And that tool, it's called IPNetInfo. And IPNetInfo allows me to specify IP addresses. It by default cuts off all the internal ones. And at that stage, if I do OK, What it does, network is pretty good over here, it shows me all of the owner of IP addresses that I ever communicated with from this machine. How useful is this? Do you guys find it useful? Thank you. Very cool. Now, the last thing that I want to show, because in Sysmon, what we are able to get, it's the information, as we know, related with hashes, and we already pulled this information out. There is a little tool, a virus total checker. You can use log parser or something. You can use even our tool to extract from the Sysmon log the hashes. And I got here hashes 1. These are all the hashes of the files that I've been launching in my system. What I would like to show you is one little thing. Virus total, it's one of the ways to check out if the file is at least known, because the file can be in the 3 stages, the good, the bad, and unknown. So I want to know that, how they're recognized from the virus total perspective. And I'm going to use for that virus total checker.exe. I will specify the mode of caching, so I will just need to load a bunch of files from the hashes 1 and -o output just local into the file. And what is happening right now, guys, is that all of my hashes are submitted to virus total, and I'm able to see if anything that I was executing ever on this machine is at some point recognized by all of the most popular antivirus engines in this world. And if there is something that is okay, fantastic. But if there is something bad, no. And if it's unknown, I also see that. So virus total, maybe it's not the perfect reference for what's good, what's bad, and that's what I'm going to be talking about tomorrow at 9 a.m. I will be talking about bypassing antivirus techniques. If I wrote my code, who's of these guys going to know if it's good or bad? Of course it's good, because I wrote it. It's not recognized by antivirus at all. So here, either it will be unknown or it will be good. You need to be very careful, but at least this is some kind of a reference that we are able to have. Anyway, guys, couple of words for the summary. Yes, time to wrap up. So forensics is a very broad subject. What is absolutely important for you to have as a takeaway from this session is make sure that you have checked if NTFS journal, so USN journal, is turned on all of your drive. Don't forget, it's not for free. It has a little impact on performance because it still has to collect data. So on the different kinds of data storages, that might be significant for you. But this, or you've got information, so you choose. Don't forget about the prefetch. On some of the drives, it might be turned off. Yes, make sure you're going to turn it on. It collects very useful information about what was executed in this operating system. Image. Before you start any of the fun that I was talking about, make a memory dump, make the disk drive. Use dump it, use disk.vhd. These are all free tools. If you want to have a takeaway home and you want to practice right now after this session, I give you everything. You've got the tools, that's the first thing. Second, the scripts. And incident response, it's one of the most important steps because whenever we are in forensics, people are, or within the attack, people are absolutely nervous, they don't know what to do. Can you believe that one of our customers called us 1 week after the attack, that he kind of wants to know what happened? So this is not how we are supposed to act. And we are like, okay, no problem. Do you have memory dumps? And they're like, what? No, we had to just restore everything and be up and running. So what do you want us to do? I mean, seriously. There is no data to work on. So make sure that you've got this list. It's just a simple steps. Tools are available there. These are the steps. And if you like, of course, what we were talking about today, after this session, there is already a blog post on my blog containing this disk recovery with PowerShell information. Make sure that you're going to check it out. I'm posting it, of course, today with all the different tools. And I am every week recording a free video on security because security is super exciting, as you see. So if you want to listen, follow me on Twitter, Facebook, sign up for newsletter or just do it all. And cool stuff on Beyond Trust booth, so the booth number 1059, come at 2:30 to participate in the tickets and in the drawing. The drawing is finally at 3 p.m., but you need to pick up the ticket. And you're going to win the laptop with all our secure tools. It's a lot of research, years of research, cool hacking tools, so that you will be obviously ready and up to perform hacking, or maybe I should say researching, yes? So this is the first thing, and pen drives with the hacking tools, and at the very, very end, one little last update. If you like, of course, everything, I was mentioning this on my previous session, we have launched an online certification program that starts in November this year, and everybody that signs up from Ignite, you don't have to pay right now, it's just enough that you sign up for the discount. You will have the early bird thing. I'm running this with my cute team. My team is much more cuter than I am, so you're gonna have a lot of fun, and there's a lot of geeky stuff and discussion about what kind of current attacks we have and how to prevent them within the 2017, because we want everybody to be updated for 2017, how to manage security within the organizations properly, and this is what it's all about. And at the very end, this is the link, and if you like the session, or if you didn't, but if you liked, that would be fantastic. Please don't forget to evaluate my session, because it's absolutely important to hear from you. What do you think about the content like this? I hope it was practical, and hopefully see you tomorrow at 9 o'clock doing the antivirus related stuff. Thank you so much.